Okay, AP Statistics. We're doing lesson 5.2 today, probability rules. Let's get into it. Okay, so now we're going to look at two-way tables, Venn diagrams, and how it relates to probability, looking at the ideas in the notation here, okay, like the words in the notation and symbols. So first things first, probability of A. That's all these events. Here's A, and so this is the probability of A occurring. So we're going to say A is the blue, A is on the left, B is on the right for all of these, okay? So you see there's some overlap here because some of the space of A overlaps with the space of B, which means they could be inclusive. So this is the probability of A occurring. This is event A. Move on to the next one. Probability of B. Well, that's going to be this column here, B occurring. And oops, you know what, we should use red because the circle's red. There's probability of B. All right. And then, so now what's the probability of the complement of A? Okay. Well, that's this row down here. This is A not occurring. Okay. And in the Venn diagram space, it's all the space that is not in this blue circle. Now the probability of not B, or the complement of B, is going to be this vertical column here, and then it's all this space in the Venn diagram that is not within this red circle, because this red circle is the event that B occurs. Now we have the probability that A and B occur. This is intersection, okay? That's the upside down U. So that's just this rectangle here, and that's just the overlapping area in the Venn diagram where both A and B occupy the same space. So here we have probability of A or B occurs, and these A and B are mutually exclusive. So this is union, so we're using that first expression we learned. It's probability of A plus the probability of B. So it's A was, remember, that's this entire row, and B is this entire column. And I wrote it equals 0. The probability of anything occurring in here simultaneously is 0. So that, I forgot to shade it in. That's the probability of A or B. It's going to be both those sample spaces there. Okay. Now we have probability of A or B, but it's inclusive, which means that A and B can occur simultaneously. Those events are not exclusive, so that's another union symbol. So we're going to use this expression, probability of A plus the probability of B minus the probability of A and B. But why are we subtracting this? Well, if you look, it's because once I fill in A, I've already filled in this space once. But then when I fill in B, I'm filling in this space twice. So I need to remove that space one time in order to get an accurate probability. Otherwise, I'm counting the overlap 2 times, and we can't do that. We don't want to do that. So we subtract it once. And finally, we have the probability of A complement and B complement. So this is an intersection, so to speak. It's where does B not happen, and also where does A not happen. That's here, lines up in this quadrant. And if you look at the Venn diagram, it's everything outside of both circles. Okay. So here I've made a Venn diagram. This is the table, or this is a Venn diagram for this two-way table. I have A represents high school graduates, so I just wrote grad, and B represents our homeowners, so I just wrote home. And so I'm going to fill it in. So we had 89 that are high school graduates that don't own a home, so there's no overlap here. Okay, we have 221 that graduated high school and own a home, so they have, what is going on here? They have to be in both circles. They both own a home and they're graduates, so they belong where the overlap is in here. Then let's go to home ownership. We have 119 who did not graduate high school, so they can't be inside circle A, but they are in circle B because they do own a home. And then we have this one right here. This is not a high school graduate, so they're not in circle A, so they can only be over here, right? But they also are not a homeowner, so they can't be in this circle either, so they're in this space on the outside, so we'll just write 71, okay? Now that we have this information, we're going to answer these questions. So what's the probability of A? So that's the probability that they graduated, okay? So we have 89 plus 221, so we look at this total here, that's 310. that did graduate from high school, and there's 500 people that they sampled, and that probability is about 0.62, okay? Looking at some other ones. So let's look at a couple others. We're skipping 2 for now. Probability of A and B, so that is a high school graduate and a homeowner. That's just this one right here. It's 221. That's where they overlap. So 221 divided by 500, that's 0.442. Then look at number 4. We have the probability of A or B. These are inclusive because I can be a high school graduate and a homeowner. So we're going to use the inclusive formula. So I have 89, so that's a graduate, plus 221, that's another graduate, plus homeowners, okay, who are not graduates, right, or B, okay, so homeowners. We're going to ignore the 71, we leave that out. What we get that from the totals. So this 310 is the high school graduate total. And then homeowner total is 340, right? Homeowner totals 340. But if you look carefully, we went like this, and we counted this twice. So that's why we subtract 221. That's where that comes from. And then when we do the math, we get the probability of 0.848, or 858. And let's look at the last ones. First, let's look at number 2. What's the probability of the complement of A? Meaning, what's the probability if A is they graduated from high school? This means they did not graduate from high school. So not a high school graduate. There's 190 of them. So we can do 190 divided by 500. We get 0.38. Or we can take the probability that they did graduate high school, 0.62, and we just subtract that from 1. So 1 minus 0.62 is 0.38. Same thing here. We have the probability of the complement of A union B, A or B. So instead of trying to figure out from the table or from the Venn diagram, we already found A union B inclusive, and it's 0.858. So why don't we just take 1 minus 0.858, and we get 0.142. So now we got a question. According to the National Center for Health Stats, they did a study from a census. 70% of households had a landline, 80% had a cell phone, 60% had both. This is so ancient. Now we wouldn't even count households. We'd be like, how many phones does each person have? We got more phones and computers than people now. Anyway, okay, so it wants us to make a two-way table. So filling this table out is not as straightforward as the last one, but we have some information that will help us. 78% have a landline. So here's landline. It has to add up to 0.78%, which means the complement is going to be 0.22. So these add up to 1. 80% had a cell phone. So here's the cell phone column. It has to add up to 80, okay? We know that 60% have both. So this is cell phone and landline, that's 60, and we use this information to fill in the rest of these squares. So we have 80% cell phone users, 60% have both. That leaves 0.20 that have only a cell phone and no landline. I'd argue this book is so old, this is actually backwards now. And then we have landline users, 0.78. That means if 0.60 is here, I subtract 0.6 from 0.78 and I get 0.18. And then rounding it out, if 80% have cell phone, that means 20% don't, because these need to add up to 1. And so if this is 0.18, it needs to add up to 0.20. I know that it's 0.02. So the probability that they have at least one of the two types of phone, this is an inclusive event. They have a cell phone or a landline. So probability of C union L. That's the probability that they have a cell phone, plus the probability they have a landline. But we're going to subtract this because we counted it twice. So we have 0.8 for cell phone users, 0.78 for landline users, minus the 0.60 of the households that had both, because we added it twice in here, and that equals 0.98%. Sorry, 0.98, which is 98%. This was more clear. What's the probability that they have C only, a cell phone only, and they do not have a landline? So using our notation, that's the probability of C intersected with L naught, or the complement of L. So cell phone, we're in this column, and no landline, well, that's this bottom row. So that's this quadrant here. That's just 0.2. We don't have to do anything else with that. So lastly, we have, what's the probability? They don't have a phone at all. So no cell phone and no landline. These are the events written out and using words. Then we're going to use our notation, the probability of the complement of C intersected with the complement of L. No cell, no landline. So that would be no cell, we're in this column here, and no landline, we're in this row, and we just look right here, it's 0.02. It's also, that's 1 minus 0.98, because what's the probability they have at least one phone? This last one is basically the complement of the first, okay? And so that's going to be 1 minus 0.98, which is 0.02, or 2%. That's it. And there's a lot in there. Your practice is going to be to reread the summary on 314, and then you're on pages? That's a typo. On pages 314 to 317, complete the following problems: 39, 41, 43, 45, 55, 61, 62. 61 and 62 are a review from other topics. Make sure you do those.